So, hello everybody. In this video, we are going to be talking about nano timestamps. So, I have created a bun instance which is running this nano private or timestamps thing, right? Basically, allows you to create a verifiable timestamp mechanism with time being a core factor for basically free using the nano timestamp mechanic using the nano timestamp and nano blockchain. So let's say I want to say some text like, uh, I don't know, it took a lot of time to really come to this point and some countless nights to create this project, right? Um, Now let's nano timestamp. Uh, let's get some private key. This can be good. Uh, Now this is creating work server, so it's going to get insanely laggy, but don't worry. And I'm going to kind of see you in some time. All right. So we have created this concatenated encrypted string. This is the main product, the main recipe. Now, do note that these are also very important, but we have just wanted to, show you the whole process. So, a nano big pen bad. All right, this has got some really nice name. Okay, so now concatenated encrypted string, we can actually go back and decrypt this concatenated encrypted string, and we can see that it approximately took us 3 minutes to do this, right? So it's really nice, and in fact, the whole string, I don't know, it took a lot of time to really come to this point, and some countless nights to get this project has been decrypted, and yes, it's really nice. But I'm going to actually talk about some things later. But I'm actually going to show you that I can quit this one server and I can rerun the whole server and still decrypt it just fine. If you have not noticed, I literally stopped the one server, reran it. It's written in Bun.js, which is really nice. Uh, it's really a fast all-in-one JavaScript toolkit, and Nano has some really good JavaScript DevOps. And JavaScript is also obviously the language of the web. So now let's talk about this code, the code creating it. So now let's see code. So basically the whole index or the whole code lies within the index.ts file. So first of all, I wanted to show you what the index.html is. So it's basically just a simple HTML server which has some form of post, and basically just a post, and then it looks for the label if decrypt works, and and then it provides the encrypted string. It's really simple. Main thing is within the index.ts, and we are going to start from scratch. So basically, bun serve is for the web server, and bun shell, this dollar is basically bun shell. Now, import star is nanocurrency from nanocurrency. Nanocurrency is a npm package which can be used in any JavaScript runtime like Node, Bean, or Bun. I'm actually using Bun here. I'm not really sure if this is supposed for Node, but it does work on Bun as well. All right. So it imports everything from the nanocurrency package as nanocurrency. Okay. So it also the index file that we see, it imports this with type text so that it can easily, you will see later on. And now this also imports blocks from the nanocurrency web and boxes from nanocurrency web. All right. So now we are using TypeScript here. So we are creating interface of an account info. Now this has a frontier. Frontier in my understanding of the Nano blockchain, is basically the last block. And if there are no blocks, the main block. And it's from where the origin starts. Balance is the current number of nano that a person has. Representative is the person which you give you voting power. In case you don't know, nano does not have a proof of work or proof of stake mechanism. It has an open representative voting model, an ORV model, and the representative is that part for the stability of the nano chain. All right. So first function is that it creates a get work function, and it uses localhost 7076, which is the server hosted basically on the nano work server. All right. So now it actually posts it, and this is just basic nano stuff, or nano work server stuff, right? Uh, and you just get the result within a JSON. And now, if there are some error within that result, we throw the error. Otherwise, we return the work generated from that result. All right. So now we have this another function called get account info. Get account info is for basically how this is working. Okay, first let's talk about how it's really working. So let's understand this. We are using Excalibur to help you understand it. Um, all right. So basically, how this works is that, and how I came up with this was I read about something called nano storage, but the original guy was really greedy and asked me $50. And this method was also really inefficient. And basically, the representative that we really mentioned, right? He basically just embeds his data within that representative model, but it's kind of an abuse vector, and it's not really the way nano was intended, right? So I really wanted to move away from that and into a model which Nano cannot really differentiate from general public transactions. And this is its main core philosophy, right? So let's say I have somebody, right? And let's say I have a user one. Now, he does not really need to know about Nano to really use this. So it's a kind of a real big revolution. And he just needs some very little, like 0.00 and so on. In this can actually continue with 10 to the power of minus 30, that is 0 with 30 trading zeros, 1, right? So 0.00, and these are 30 zeros and 1. So this is the minimum amount that you can send. So of course it's really negligible with the current price of Nano being something around 1.06. And you can actually use something like some faucet to get Nano for free, and without having to worry about losing that Nano using the transaction process, since it's Nano is really efficient and you don't really lose Nano within sending money. All right. So let's say this user. Now let's redraw it. Let's say a user A, showcased by the green box, wants to prove something on the chain. So what he can do is that he can go and hook to some client, right? In this is API of the Nano. Since Nano is just created by the voting model, so there are big nodes which host and API, so you connect through them basically, right? So in this case, we are using the Natrium API. So what it's really doing is connecting to the Natrium API. And what is it doing with the Natrium API? Well, it has its own server, and it has its own private key, right? And so the private key can then be used combined with the text that you have wrote, and now that text gets converted into a bow hash. What is bow hash? Well, bow hash is basically incremental verified streaming. something which kind of inspired and was inspired, I'm not very sure, by the Blake 3. And Blake 3 is really fast and it's really great. And Bao is created by O'Connor, the singer who created Blake, the IS. So this uses Bao hash on this text. Now, the point about hashes is that they are one-way functions. So, to really get this hash out of randomly, the person, it's really unlikely, right? So, he really needs to own the text to really create the text in the first place to then create the hash most likely. So this really links a hash with a text. Now text can be on of a very unlimited amount of characters, right? But the bound hash is fixed. So now with it being fixed, luckily there is also another thing that you should know is that bow hash is the exact character length that is needed for a seal of Nano or a private key of Nano, right? So basically, what you can think of private keys is that they can allow a user to create a first private public key from that private key and do transactions. And so you really own a account if you own the private key. And basically, we have created a text which converts into Pau hash, which then converts into a private key. And now with this private key, you have gotten a Nano account and you can generate a public key and an ATM, a Nano account with the infamous Nano's bracket underscore some some characters, right? And now you can use, and what this project basically does is that it takes the money, all the money from your Nano account, uh, let's say Nano account, which has money, let's say from a faucet that you bought it, and it transfers this money to the second account, the hash account, right? And the idea is that the hash account is so rare that nobody else except the creator of that text, which created the hash in the first place, can really access it. And now you have this. And then once the transaction happens, uh, they really send back, and this creates a loop where the money gets sent to the first person back. Now, the interesting part is that for a transaction to occur, you actually need send and receive. So this party has to send once and then receive once for because the money has transferred, and this also has to send once and receive once. So the total amount of work that has to be done is 4 work server keys, I guess. So 4 is the amount of generating keys, right? So now this is how it works. And basically, all of this data of like, hey, this is my private key, this is the public key, and the transaction ID of this happening, and the date attached, it actually hooks all of this into a really neat encrypted string. And so you don't have to trust anybody. You can just give somebody this encrypted string, and yeah, it would just work out of the box. And I think the main power of Nano is that you can actually increase the amount of trust. So let's say you are firstly trusting this one server. Well, now, and but what if that one server turned out to be malicious? Well, now you can take out multiple servers like, uh, some others instead of using NanSwap API, and you can even create your own node system or Natrium or whatever, right? So this was a really basic understanding. Now, let's see how the code works. So we were on the async function get account info. Basically, this takes an address and it creates a promise with that account info of the account info, right? Because this basically just uses the Natrium API, and if data is not found, it results the frontier into zero with balance zero, and I think this is for the natrium. I'm not really sure. For XNOP, I'm never find. Right. This, generally speaking, does not really matter. From my understanding, Binance is the biggest representative with 40% funds, whatever, right? And for that, in this returns the data dot frontier, the data dot balance that it gets as a response dot JSON, and it just converts it into the current format. And if there is an error, it throws the error. And not really great issue handling right now, admittedly. All right. So it sees if there are a pending transactions, right? Pending transactions are basically if some transactions are pending and they need to be done. Uh, Basically, something the receivable action. So it sees if there are, uh, it partly patches the Nano Natrium IO API with the method of post, and they had also the basic JSON, and the bot is just a stringified JSON where the action is receivable, the account is the address, and the count is one, and threshold is one, right? So this can then create a result from that response.json, and now it would also console.log the results. In fact, you can see this receivable result, right? This is the main thing, right? It created blocks. Mm. All right. So now the pending hashes, it can create the number of pending hashes and solve that. So there is also a simple delay function that we had to implement. I'm not really sure why we had to implement it, but it was basically because this would kind of either the APR would call out and you needed a delay, or the bug server really took a lot of time. It took 3 minutes on this project. So yeah, now this was actually a huge revelation, as I remember, because it was really like the code in theory should work, but it wasn't working. So I was just scratching my head and delay kind of failure. I think Chad created this. So yes, this project was created with the author of this competition as well, and I thank him with this as well. It wouldn't have been done without his help. So now, what it really does is it takes the last transaction time, which is what was really offered here. This last transaction time from a from guy to do guy. Yes, the names are not that, but I just wanted for it to understand. I just wanted a simple mechanism, right, from where I can find the last transaction time from A to B, and I was just a from guy to guy, like so it uses bun.fetch to do another response, and it sees it just sees the account history of from guy with a count of 100. So okay, maybe the count should be really increased, but it's kind of open source. So if you have to see something which is far back in the future, far back in the past, well, you can, and you can increase this count number, right? Okay, so now this will get a response.json, and if the data of history does not exist or the length is zero, it will give you an error of no transaction history found. So now it does a for loop of all that data history, and it sees the amount of send that is sent to our to guy, and it returns the date of that time of whenever it was to the do guy, right? Or within that local Natrium server. On let's say that Natrium server hosted this transaction and recorded it with the timestamp of something. So this timestamp is the timestamp which it took for the Natrium server for the last transaction to occur. All right. And there are some errors. It would have this return timestamp not available. Let's say Nitrum goes down or no Nitrum accidentally removes the timestamp or whatever, which is highly unlikely. and you can use any other server. You can use your own voting node if you with your own API. So there is no locking, right? Which is really nice. So now if also this has some error, it would throw this error and it would return the error message. Now, this was also another revolution. I just wanted these simple building blocks of receive funds, send funds, transaction to guy from guy, right? So we discussed the last one. Now let's talk about receive funds. So basically, receive funds takes a private key and it takes a hash, and it uh, basically it does work to accept that hash and gives that block, right? So cost basically it now why do we need a private key? Because receive still requires access to that private key because you know how basically it's part of the nano and cryptocurrency structure, right? But most cryptocurrencies don't have a receive a part counterpart to the send counterpart. Like how let's say I want to send money from Bitcoin from A to B, then I just need to get access from the account of A and deliver the funds to B. But now let's say I kind of want A and A to send money to B and B to really receive it without doing any work later on. Well, I need access of B as well for the B to receive it. Receiving is basically done to prevent scam within the nano ecosystem, I guess. So now this can receive funds. So this is highly, unstable for some, basic ecosystem like, hey, I want to send money to your account without you having to work. So, you give me a private key and everybody would see it as a major security loophole. But our goal is for it to be actually publicly open so that we can prove that we are the first guy to send money. So we are not really caring about that money. So that money comes back to us in our own private key, but we just wanted a kind of timestamp, a footprint of our, timestamp basically, that we created this hash uh, on the Nano ecosystem. So firstly, it creates a public key from that private key, and then it creates an account address from that public key, and then Uh, frontier is set to zero. The current balance is set to zero. Most of the 99.99% cases, it's this. So, and again, you can commit if you think that our code is really too neatly packed. I mean, we created this for our own use case. So, it might not be that well suited for your use case, which can be more general. But for 99% cases, I think this can work. So, now, once we do a try, uh, we do a const info on the await get account info account address. So it uses the get account info function to get the information of the account address, like the uh basically that promise that we had discussed right now. This console.logs this information logging. Yeah. So this then sets the frontier to then the info dot frontier. So even if the frontier is something else, well, that issue also gets fixed because the frontier is now taken from the blockchain itself and the balance is also taken. So it was just a countermeasure for a really short time and it should not have an impact. So this should work for 100% of the use cases. But still, if you feel like there can be some improvements over this code, well, you can just code is create licensed under the MIT, and you can upload GitHub issues on this, right? So now it will also catch any errors, the general thing, and it also console logs the current balance and depending amount. Now we are working with this can actually have some issues because the 10 to the power 30 that I mentioned, right? So this creates a really big number And this big number is kind of hard. So we wanted strings without any scientific notation. So we are using this change current balance and pin penny amount. Now we will calculate the new balance from the clean current balance and the clean penny amount. And we will console log this. Now we will do the work. We are doing work from the network server, which is calling the Nano work server on localhost 7076, which is actually doing the work. And when this does the work, it actually signs the block using this receive data and private key to create signed block. And then it sends this to process on the app Natrum API, right? And it also sees if there are any errors within this and it throws that errors. Now, what it does is that it returns a hash and it returns a block. Now, what this does to for funds is basically, first of all, it sets the default representative to Natrium, and then it derives a private key, public key from the private key, and it derives a standard address using the nano prefix. So that would be something like the famous nano underscore something, right? So now it console logs this. Now account info, it creates from the get account info function that we discussed earlier, and now it also console logs this. So then the work is actually created again to transfer all the funds, and now the generated work is also logged. And now this is very important because this is the sending block data. So what it takes is the account info balance from the address to the address and the representative and the frontier and the balance, of how many. So you could, if I, let's say, send 1 nano, then I just needed to change this amount row. Row is within the 10 to the power of 30 row is equal to 1 nano. So this would be some huge number, right? Astronomical number. And then it is the work. This is very important since work gets old every time you do a transaction, whether it's a send or a receive. So it totally takes up 4 times. So you will actually see something where this over 4 times really happens within the core. Now it creates this sign block and it sends it to Natrium API. Natrium accepts it and it gets validated into the blockchain. And now it returns the hash and the block, block within the nano system, and it catches any errors if there are. Now, basically, this was it. It now takes this is the main server function. If there are any get instances, basically the slash, basically when we go to localhost 8000, it runs on port 8000. So it basically just sends this HTML within the index.html and with the context type text HTML. So now, if the request method is post, which is within the form method, right, which the user can access using HTML.static, and then this creates the form data from the request.form data, and then it basically concatenates it and turns it to kind of get a concatenated string. And then, okay, so basically this is for the concatenated strings part, and it returns the derived address, the bow hash, and the encrypted, and from that concatenated string. So and then the derived address bow extract strings. Now the decrypted is actually decrypted using the box.decrypt. So it's actually encrypted. So nobody within the middle can kind of see that if only one value is given. So now derived public key from bow is basically nano currency dot derived public key bow hash, and derived address from bow is this derived address. And this is the get last transaction derived address time from bow. So we are actually seeing it from BOW itself. And, it's also, when we created the decrypted last time, then it's that within the new response. Now, we will also catch some error like error during decryption with the catch. Now, uh, so this is the main really important thing, and this is the very neat. All of the things about it, I think they can be used by anyone creating their own nano inspired something. So any project, right? But this is the project implementation code which really matters for our own implementation. There, the text is taken and the nano private key is created from that nano private key from data, and then it creates a new process of bow hash the text. It uses the one style here in that 290th line, and now it creates that bow hash from the process to output.trim. So here I'm actually going to show you how that works. Let's say I create a file hello and I say hello world, right? And now I open up a new terminal. Okay, and now I do bow hash hello, and you see this. Now this is so if now I change this hello world test, as you can see, this really changes. So this is how it works. And basically the output that we get, we actually store it within the bow hash variable. And I think one shell really simplifies a lot of things. So we also console log fix, and now the derived public key is taken from the bow hash as a private key. As I mentioned, that bow hash and private keys of Nano, they are of same length and they're generally valid. I think Nano private keys come from an idea like bow, but I'm not really sure. Their address is taken from that derived public key and derived public key of Nano Plus. Oh my God sucks. I'm back. It works. So with nano currency dot decrypt. So it's from the R private key that we had actually inputted. So this the okay, it's not running. Z mango one index OTS. So it's basically like test. Then yeah, of course it's not going to work because it's not valid. But it's basically the private key of this, which are called the decrypted address. No, derived address of nano private key. Okay, it's look like I'm reciting a really long project, but it's really not that. It's just that basically four transaction keys and a loop, and you kind of just put a fingerprint on the nano chain, but it's sort of encrypted. So this text that you give to anybody, that is what really signifies the timestamp. Otherwise, it's just going to look as a normal transaction. All right. So now that this has created a derived public key, it generates a direct address of that nano private key, and it confogs this as well. And it creates the box.encrypt of text with derived address and nano private key, and it also logs it as well. Now, it also sees the first transfer result. So this is the first transfer. This is the code I was really talking. This is what is important. Yeah. So first transfer result is that it transfers all the funds from the R nano private key to the derived address. And now it will, look for all the work and do all the things because that was already created from our transfer all funds function. Then it creates a first receive from the bow account claims pending funds. So pending transaction, it gets the pending transaction and it receives funds. of from a private key, which is bow hash, to the pending transaction for bow. And it delays for the network to propagate. Okay, maybe these 550 seconds delay or 5,000 are also sort of, but I think they were necessary. Okay, so now the first receive happens. Now the second transfer happens from the bow server. Okay, so the bow server or the bow hash private key is public derived, not really derived, public key created from the hash of a text, right? Like that public key or that nano account has now funds, and it transfers it back to the original author or the owner of that, nano token. So it does the second transfer of a transfer all funds, and it basically just logs it and creates a delay for the network to propagate, and then it creates a second receipt, a way to get pending transaction. If there are any pending transactions left, it console logs it. If the pending transaction is there, I guess, and it's checking all receipt funds are done, and it is console logged. Now, all these values, the concatenate strings basically just takes all of these derived address, bow hash, encrypted, and functions. And basically, basically, this is a very small function. And the concatenated encrypted string basically concatenates the derived address of the nano private key, the bow hash, and the encrypted. So encrypted rows are original text, which is how, if you just send encrypted won't do anything, because you need bow hash and you need the derived address of the nano private key. But to get both of these, you kind of need the the bow hash in the first place. So yeah, now when you return this response, basically this returns this response, and it catches the errors, and anything else method not allowed. Thanks for watching. I guess this was a really big video, and if you think that I wasn't able to explain something well, you can ask me in the comments. Thank you.